I would like to introduce myself. I'm Dr. Phiros Mansur from the Department of Computer Network Engineering. Okay, here I'm going to deliver a lecture regarding the embedded systems and microcontrollers. We have very short time period. Within this short time period, inshallah, I will try to deliver you some basics of embedded systems and microcontrollers. After that, if time allows, something about the microprocessors also, inshallah. So let us start with this outline. We have some definitions of embedded systems, and I will show you some examples. Then computer essentials, microprocessor and microcontroller a comparison. Then PIC microcontrollers, inshallah, we will go through these points. So what is basically an embedded system? A computer system designed to perform one or a few dedicated functions, often with a real-time computing constraints. Embedded system, when you hear this name itself, it is basically for a specific system. It is basically for a specific application designed system. Okay, there will be limited functions. There will be dedicated functions only in the embedded system. So one embedded system design means it is for that particular system only. And it is controlled by one or more main processing cores. That is maybe sometimes a microcontroller or maybe a processor. Okay. So a formal definition we can give for embedded systems like this. It's a system whose principal function is not computational, but which is controlled by a computer embedded within it. Okay, the processor or microcontroller embedded within the system will control the entire activities which are required for this system. So this can be taken as a formal definition for embedded systems. Now, implementation of the embedded systems. We need a microcontroller. A microcontroller means it's independent system consisting of all the components, like the memory, processor, different I/O ports, okay, serial communication ports, etc. So all the basic requirements for a system will be inbuilt into a single chip. That is what is a microcontroller. Okay. And PLC, you know, a programmable logic controller. So it can be a microcontroller or a microprocessor. Will be the core used in the this kind of PLCs we are using in the industrial projects. Some examples for embedded systems we can see, like the refrigerator. So what actually is a refrigerator system? How it is controlled? So there will be a microcontroller. And along with the microcontroller, some embedded programs will be there to control the temperature, to control the activities of the refrigerator. So definitely it is a human interactive device. Always it is having human interaction. So there will be variations of the temperatures and many things has to be taken care of. So what happens when the temperature changes? The microcontroller, with the help of the embedded system, it will control the compressor, okay? And it will give, if it is required, it will give the alarm or the display, or any warning is required, it will give. So this embedded system is only designed for the refrigerator, okay? So like this, we can see some other examples like a car. The modern cars are coming with many embedded systems inbuilt. For example, the window stall sensors, window control buttons, window motor, lock control, lock actuator, open door sensors, many things. Okay. Apart from this, we can see hundreds of things within a car, which is examples, which are examples for embedded systems, okay, automatic controls. Another one, it is autonomous guided vehicle like a robot, okay. We can control this using the remote controller. So here also we need a microcontroller and inbuilt programs. So these are all examples for embedded systems. Now let us see some of the computer essentials which are related to the embedded system and microcontrollers. From the outer view, from the top level, if we see the computer, we can see the input output, we can see the central processing unit, we can see the data memory and program memory. Okay, the input output unit is responsible for the outside communications. So we can generally represent a computer system like this. Okay, the user interaction will be with the input output device, and eventually it will communicate with the CPU. CPU is having the back support of the data memory and program memory. When we see the architecture of the microcontrollers or even the microprocessor, we can see two different architectures. This is common for the computer systems as well as the microcontroller based embedded systems. Okay, we can have two architectures. First one is the von Neumann architecture. Okay, von Neumann architecture, we have the CPU, we have the data memory and program memory, okay, and input output. All these are connected by using the address bus and data bus. But in the Harvard architecture, the major difference is in Harvard architecture, we have a separate data memory and separate program memory. And we have separate address and data buses also for each of these memory. So parallelly, the data memory and program memory can be accessed. Independently, we can operate on these two memories. So this is the major difference between Harvard architecture and von Neumann architecture. In von Neumann architecture, see, you can see the buses. We have only one set of address bus and data bus sharing among all the memory. But here we have different individual set of address and data buses for the Harvard architecture. Okay. Let's see a comparison between microprocessor and microcontrollers. The microprocessor is a processor on one silicon chip. Okay, this is only a microprocessor. The microcontroller are used in embedded computing. Okay. The difference between microprocessor and microcontroller is in the microcontroller based systems, we have separate memories, separate RAM, separate ROM, and other input output devices. Okay, all these units will be separated, but it will be connected by using the buses. But in a microcontroller, it is a single chip embedded with all these memory and input output ports. Okay, it is a single chip which serves, which provides the facility, complete facilities of a small computer system. The architecture, when we see for the microcontroller, you can see mainly the processor core, microprocessor core will be here. Okay. When we say microprocessor, it is a microcontroller or CPU. Just assume that it is a CPU. And we have the memory for program, memory for data. And there is a common system bus, which is connecting all the devices. We have a digital input output port, an analog or input output port. Okay. Then we have counter and timers. And further peripherals means additional peripheral devices can be connected. There will be a sufficient number of ports provided in the microcontroller system. Okay. And definitely there are the power sockets, power pins, reset buttons, and clock signal. So this shows a microcontroller architecture. Yeah, as I told you before, microcontroller can be treated as a small computer system on a single IC. The first microcontroller introduced was by Intel company 8048, the year of 1975. The introduction of E-square PROM or EEPROM. Okay, what is EEPROM? Electrically erasable programmable read-only memory, that is EEPROM. In 1993, because of the introduction of this EEPROM, it allowed microcontrollers to be electrically erased. The same year, Atmel is another company. It introduced the first microcontroller using flash memory. We can see a microcontroller is a specialized form of microprocessor. Okay, specialized means the application oriented. It will be for a microcontroller will be for a specific application. Okay, for a specific purpose. It is designed to be self-sufficient and cost-effective. The cost-wise, when we see microcontroller is a cheap device. Okay, it is very less expensive. Microprocessor is an expensive device. Also, microprocessor is typically designed to be a general purpose device. Okay, so these are some of the differences between microprocessor and microcontroller. A microcontroller incorporates features of microprocessor like CPU, ALU registers. I told you before. Some additional features we can see like RAM, ROM, IO ports, counter, timer, serial port. So all these features are added in a microcontroller. It controls the operations of machine using fixed programs stored in ROM. Yeah, these are the microcontrollers fundamental components we have seen already: CPU, core, memory, both the ROM and RAM, some parallel digital IO. Okay, some of the major components of the microcontroller. The basic diagram, basic architecture or the block diagram, we can see like this. There is a CPU, okay, and ADC means analog to digital converter. Then we have RAM, random access memory. We have ROM here, read-only memory. We have a timer. We have input-output ports. Okay. Depending on the microcontroller, the number of ports will be different. So here we can see 3 input-output ports: port A, port B, and port C. Apart from that, there is a serial communication port. Okay, so one line will be for the transmission and one line will be for the reception. These points already we have seen in the previous slides, so let me go fast. Basic microcontroller architecture, bus. Okay, you know what is a bus? Bus, we can define bus as a set of parallel communication lines. Okay, bus can be defined as a set of or a group of parallel communication lines. Okay, so we can see different types of buses like address bus, data bus, and control bus. Okay, so here the size of the bus actually for different microcontrollers or different microprocessors, the size of the buses will be varying. Okay, it depends on the processor or the microcontroller. So it may be 8-bit or it may be 16-bit or 32-bit, depends. Input output, as I told you already, we have 3 ports: port A, port B, port C, yeah, input output ports are bidirectional. Bidirectional means the data can flow in 2 directions. Okay. Generally, address bus will be unidirectional because address bus flows in one direction only. Normally, it will be from the processor or the microcontroller to the memory device or the input-output device. So address bus is a unidirectional bus, while data bus and other buses are bidirectional. Serial communication, I told you, timer, watchdog, it means automatic reset to prevent the stall. Analog analog to digital converter. We have the provisions for analog and digital data, or analog and digital signals can be processed by the microcontroller. So there are separate dedicated lines, dedicated pins available for the analog as well as digital. Okay. So a converter is required to convert the analog to digital for the processing purpose. Okay. Sometimes we need the reverse also, digital to analog, DAC. Okay. It is not so fast and accurate. Atmega 8 contains 10-bit approximation ADC. Then internal and external reference voltages can be used. There are some additional features. Okay, let us go for the next important slides. Block diagram. We have seen one block diagram. That is enough. This block diagram gives a more specific explanation of the registers and the internal organization of each of the blocks. Like, for example, the memory, the CPU, I/O port. Okay, it gives the internal registers and internal memory allocations. So this gives some programming aspects. I don't think it is. We have record because of the time restriction. We have no time to go for the programming aspects. Just I tell you, yeah, microcontroller understands only the hexadecimal code, hex code. Okay, so generally when we write the programs, we better to use the assembly language. And when we use the assembly language in EMU 8086 or any other assemblers, hex codes are used. So any language must be converted to its equivalent hex code, and we can use the assemblers to convert the assembly language program to the corresponding machine language. Okay. So EMU 8086 is one of the best simulator for programming the microcontrollers. Just simulators, yeah. EMU 8086 is an emulator, or a simulator. It's almost similar tools. Okay, we can use simulators for programming. Some of the applications for microcontroller and embedded systems. It is used in any smart systems. Okay, suitable for lightweight electronic devices. It's used in microwave automobiles, electronic locks, calculating devices, automatic ticketing systems, and many other examples we can see. Microcontrollers and robotics is another big area. You know, the artificial intelligence and the robotics have now it is having very relevance. So the scope of microcontroller and the embedded systems is very high nowadays. Microcontrollers are vastly used in robotics, and it is used to control the robots. Can be automated or outside control, and limited intelligence. So one part of this presentation is over.